Hello folks, and welcome to your next installment of your MLOs for Math 2201. So to help you along with your learning in that course, today we're going to start a new unit called Quadratic Functions, and we're looking in chapter 6, which is unit 7 of the course. We're talking about an introduction to quadratic functions. We're going to focus on the equation of a quadratic function in standard form. We're going to look at what we think is the simplest quadratic. We're going to talk about parabolas, which are the graphs we get for quadratics. And then we're going to talk about the properties of those graphs. Okay, so let's make some sense out of all that jazz. So, last year in grade 10, you studied something called linear functions. So this table sort of gives you an overview of where this idea of a quadratic function fits into the universe of mathematics here. So what we're going to do is we're going to talk about all these different kinds of functions that we have here. And we're going to talk about their similarities and differences. So the first thing we can do is we can just take a simple number. So you can take 7, you can take pi, or you can take negative 357. Doesn't matter. And that number, we're just going to say, could be any number. So we're just going to call it a to be non-specific. But it is a constant. It's not a variable. And if I say that y has to equal that number, then y can't change if it has to be equal to that number. So we call it a constant function. Okay? So it doesn't matter what number you choose. That's why we're calling it a for now. But that's a constant function. Then in grade 10, what you did was you took a simple number, we're going to call it b in the second instance here, and then you added this a, so some other number, multiplied by the variable x. And we let x be anything it wants, and then we see what happens to y. And when we do that, we get a graph of a whole bunch of points that we call a linear function because it gave us a straight line graph. Okay? In this course, we're going to focus on this level right here, which is what we call a degree 2 polynomial function or a quadratic. So basically, these two terms down here look just like the linear. We changed the letters, but that doesn't matter. It's the same thing. A number times x plus a constant, or a different number. Then we add another term, a multiplied by x squared. And that's what we call a quadratic function. So this is the third type of polynomial, and it's what we call a degree 2 polynomial, a quadratic. This form of the equation that we have written here is called the standard form. So we see that quite often, and we'll work a lot with that in this unit. If we add another term, we call that a cubic function. If we add a term that's a number multiplied by x cubed, and if we add a number multiplied by x to the power 4, we call that a quartic. So there's sort of no end to how far we could go with these things, but the idea is right now where we are, we're dealing in the land of quadratics. And that's probably one of the most important types of polynomial functions. Lots of applications, and helps us understand all the other forms. The degree of the polynomial, just as a side note, just refers to sort of what the highest exponent is you see on any of the values or any of the x's there. So for a constant function, there's no x at all, so we say it's degree 0. Then when x has a power of 1, we say degree 1. For quadratic, it's degree 2, etc. Okay, so that's what that's all about. Now we're going to talk about the simplest quadratic function. So remember we said all quadratics are going to look like y equals a times x squared plus bx plus c. We call this the quadratic term, the linear term, and the constant term. The most important term for us to have, if it's going to be a quadratic, is obviously the quadratic term. So as long as we have an x squared, and no power is bigger than x squared, we have a quadratic. These other terms, we can have them, absolutely, but we don't need them for this to be a quadratic. So what we're going to do is we're going to choose numbers, just to make an example now, for a, b, and c, to make the simplest quadratic we can think of. So if we want these last two terms just to go away to make things as simple as possible, we can choose b and c both to be equal to 0. But if we want to keep that squared term, but make it as simple as possible, then 1 is a good number to choose. So when we plug all that in there, we end up with y equals x squared. This is the simplest quadratic function. And what it does is it shows us a relationship between two variables, y and x. So whatever number we choose for x, that's what we call the independent variable, we get the value for y, the dependent variable, by squaring the number we chose for x. And that's basically what it means to be quadratic. Y is x squared. Okay? So we can create a table of values then. We choose a whole bunch of numbers for x. We figure out what y would have to be because our equation over here says that we have to square x to get y. If we square all those numbers, we get these ones. So for each number x, we have a partner y that is x squared, and they give us a whole bunch of what we call ordered pairs, x, y. So for instance, 2, 4 is one of the ordered pairs. And if we plot all of those ordered pairs, There's the number 2, or the point that we get when we go over 2 for x and up 4 for y. We get this graph if we were to plot as many as possible. And this graph is called a parabola. So we get this sort of U-shaped graph. It's symmetric, so it's identical on both sides for the simplest quadratic. Okay, and that's what we call the simplest parabola. So parabolas, and here's a bunch of examples sort of thrown over here on this graph. As long as they have that nice symmetric U shape where they keep opening out and going up or down forever, it's still a parabola. We get different parabolas by simply choosing different values for A, B, and C in the very beginning. We chose 1, 0, and 0 to get the simplest one. All other parabolas are just choosing different values of A, B, and C, and we call those transformations of our simplest parabola for y equals x squared. All right, so we're going to look at, no matter what parabola we get, there are certain features that they all have that are going to be consistent. They all have something called an axis of symmetry, which is this sort of blue line that I drew right down the center here. The axis of symmetry is just like you did in grade school when you had those mirrors and you would look at reflections and stuff. It's a line of symmetry right through the middle of your graph. And the axis of symmetry, you notice for this particular example, everywhere on this line that we have for our axis of symmetry, the x-coordinate would be 5. So we just say this one has equation x equals 5. That's our axis of symmetry. The second thing to notice is they all have a vertex. Even if you look back at some of the other examples we have, whether they open up or down, there's always that one point that's at the very bottom of the parabola or the very top of the parabola. So it just depends on which way we go with it. This one has what we call a minimum value because there's that point at the bottom, but that's called the vertex, and all parabolas have one. And then there's the direction of opening. They either open up or they open down. This one opens upward. It's closed on the bottom, open on the top, so we say it opens up. So just a quick review. Quadratics are polynomial functions of degree 2. They look like this in standard form. Y equals x squared is the simplest quadratic, and it gives us the simplest parabola. Changing the values of A, B, and C create different transformations of that simple parabola. So 3 key features of parabolas that we have to look for: axis of symmetry, direction of opening, and the vertex. Hope that helps.